Assalamualaikum and hi everyone. My name is Nurul Shazwani binti Azman. Together with my team members Muhammad Shazwan bin Lay, Nur Fariza binti Isa and Nur Zarifah Huda binti Hashim. We are from University Technology Malaysia, Faculty of Built Environment and Surveying, majoring in Science Geoinformatics. Today, I would like to present my second group project for Survey and Mapping 2 subject with course code SBEG 1373. In this video, we will be focusing on the conversion of coordinate system from CASSINI GEOCENTRIC to MRSO GEOCENTRIC. The objective of this project are to understand and processing the conversion of coordinate system. There are two types of coordinate system, which is geocentric and geodetic. What we are going to show today is the conversion of both geocentric coordinate, and I am going to explain further what is geocentric coordinate system, why it is produced, and the advantages of geocentric coordinate system. We will also give an example to convert one coordinate system from CASSINI geocentric to MRSO geocentric. Back then, when there is no geocentric coordinate system, there is an issue arises where the distortion occur in local datum. For example, RSO and CASSINI solar map projection system that is used for national mapping and cadastral purposes. These systems having its advantage in terms of reducing scale distortion for a point located away from the central meridian. However, for a larger area such as state, the magnitude of the distortion is very significant away from its origin. Therefore, to solve this issue, geocentric coordinate system is introduced. Geocentric coordinate system is used to accommodate the present and the future interest in the acquisition of digital spatial data related to cadastral and topographic mapping information. The highlight is to provide a homogeneous geodetic infrastructure as the basis for integration of spatial data for sustainable development decision-making. They recognize the shortcoming local datums and then propose that the country need to adopt a new geocentric datum for its acquirement of 3D geodetic spatial referencing. The figure shows the relationship between various coordinate reference systems. As we can see, Box 1 is coordinate conversion between geographical coordinate and Cartesian coordinate. Box 2 is transformation between various datum using Bursa-Wolff formula. Box 3 is map projection of MRT68 or BT68 geographical coordinate to rectified skew orthomorphic RSO plane coordinates. Box 4 is coordinate transformation from RSO to CASSINI using polynomial function. Box 5 is map projection of GDM 2000 geographical coordinate to geocentric CASSINI plane coordinates. Box 6 is map projection of GDM 2000 geographical coordinate to geocentric plane coordinates. And lastly, Box 7 is datum transformation from GDM 2000 to GDM 2000 latest version using multiple regression model. Geocentric coordinate systems have their direction of the axis defined arbitrarily. The advantage of that is they can provide seamless positioning across the world, and they can relate directly to the modern space-based positioning system that is being used nowadays for various purposes including surveying and mapping. There is a change occurring in the datum of coordinate system used in Malaysia. and that will affect not only mapping and spatial data users. Adopting a geocentric datum, GDM 2000, will provide a single standard for collecting, storing, and applying spatial data. This will ensure compatibility across various geographic systems locally and globally. The key advantages of GDM 2000 over the existing local datum is it really compatible with satellite-based navigation system, including GPS and major international geographic systems. This will minimize the need for casual users to understand datum transformations and allow more efficient use of spatial data resources. By reducing datum, will promote GPS, GIS, and navigation system become more widely used in the country. The Cassini projection, also known as Cassini-Zollner projection, is a map projection described by Cesar Francois Cassini de Thierry in year 1745. Cassini geocentric is coordinate projection system that was converted from the state-based localized Cassini-Zollner system after geocentric datum is adopted. This conversion allows efficient data exchange and sharing from various information systems compatible with global systems. The rectified skew automorphic RSO map projection is an oblique Mercator projection used in topographical mapping in Malaysia. This projection is orthomorphic, conformal, and cylindrical. The RSO provides an optimum solution in the sense of minimizing distortion whilst remaining conformal for Malaysia. Its scale factors varies from 0.9998 to 1.0016, leading to a maximum scale distortion of 1 is 6,250. There are two ways to convert the coordinate system: by mathematical formula and using open software such as ArcMap, GDTS, MapInfo, QGIS, and many more that can be obtained from web or purchases. Now, I will explain on how to convert the coordinate system by using mathematical formula. Transformation or conversion can be done by changing a coordinate in its existing projection to the geographical coordinate. The reverse process of coordinate system transformation from Cassini-Zollner to MRSO is performed by using the following equation. In this equation, we can find northeast-easting MRSO geocentric or northeast-easting Cassini-Zollner. It depends on the conversion that we want. In this case, we want to convert Cassini geocentric to MRSO geocentric. So, we are going to use the first and the second formula, which is the first line of the formula is for northing MRSO. For the second line, it is for easting MRSO. Looking at the first line of the formula and northing MRSO, we need delta northing Cassini plus northing origin MRSO plus R1 plus XA1 plus YA2 plus XYA3 plus X2A4 plus Y2A5. Moving on to the second line for easting MRSO, we need delta easting Cassini plus easting origin MRSO plus R2 plus XB1 plus YB2 plus XYB3 plus X2B4 plus Y2B5. Looking back to the formula, we need to know each of the parameters. Delta northing Cassini is where Cassini coordinate minus Cassini coordinate of origin north. We already obtained the value of Cassini coordinate while for Cassini coordinate origin, we can obtain this value from Japan. Same goes to the delta easting Cassini. Moving for NO-MRSO, which stand for Northing Origin MRSO, and EO-MRSO is Eastern Origin MRSO. We can obtain this origin from Japan. X represent delta northing of Cassini or MRSO divided by 10,000, and Y represent delta easting of Cassini or MRSO divided by 10,000. Next, for the parameters Ri, Ai, and Bi, where I is equal to 1, 2, until 5, it is stand for the transformation parameters. Once we substitute all these values of parameters into the formula at the end, we are going to obtain Northing MRSO geocentric and Easting MRSO geocentric. Note that by performing transformation between MRSO and Cassini-Solner projection by using this equation, it can causes the distortion on the shape, areas, distance, and direction of the original position of each soil and land use properties. Neither it is in 2D or 3D perspective.
For the conversion of coordinate system from Cassini geocentric to MRSO geocentric, we are using ArcGIS as the software. First, we simply add the data to the layer. The data that I chosen is Sungai Cassini. We simply add it and the data will appear in the data view. So we're gonna look at the properties. As you can see here, it is GDM 2000 State Cassini Johor. So we just proceed to the next step. Just click OK and go to Geoprocessing, up Toolbox, Data Management Tools, and you search for the projections and transformation. And click Project. Double click for the project. Okay, so here we see the input data, input coordinate, output data, output coordinate. So for the input, we choose Sungai Cassini. So it is stated. For the output is what are we going to change to, which is for our group we have to change it with MRSO geocentric. So search at the column, and from here we can see the parameter, the longitude of center, latitude of center, azimuth, XY plane rotation, unit, and others. Then we click OK. Then proceed OK. So here at the layers, it will appear Sungai project which we have converted to. It is purple in color, while the Sungai Cassini is green in color. So we're gonna confirm. Go to properties and look at the projected coordinate system. It is stated as GDM 2000 MRSO Peninsula Malaysia. So the data is now converted to MRSO geocentric.